Welcome back. In this video, we are going to solve a structural design problem that involves a cantilever slab design using LRFD method based on eStructural Design Zen found on the App Store. Design a reinforced concrete cantilever slab using load and resistance factor design for light manufacturing use with 2000 mm span and assumed thickness of 200 mm. Design criteria as follows. Strength of concrete 42 MPa, main bars 10 mm bar grade 414, temperature bars 10 mm bar grade 414. The uniform load for 200 mm thick slab is 4.8 kN per meter. A light manufacturing live load is 6 kN per meter. Other dead load like floor finish and partition is 1.92 kN per meter for a factored load of 17.664 kN per meter. Enumerate input parameters required. Name of slab CS14, type of support cantilever, length of span 2000 mm, slab thickness 200 mm, main bars and temperature bars 10 mm bar at grade 414, strength of concrete 42 MPa, and factored load 17.664 kPa. Given factored load equals 17.664 kN per meter and L equals 2 meters, the maximum moment is 35.328 kN meter. Given maximum moment equals 35.328 kN meter, resistance factor equals 0.9, B equals 1000 mm, and D equals 175 mm. The beam design ratio Rn equals 1.282 MPa, and reinforcement ratio Rho equals 0.00315. Use Rho minimum of 0.00391. Given Rho equals 0.00391, B equals 1000 mm, and D equals 175 mm, the area of steel for main bars is 684.25 square millimeters, and the spacing for 10 mm bar is 110 mm. The area of steel for temperature bar is 360 square millimeters, and the spacing for 10 mm bar is 215 millimeters. The shear force from dead load is 13.44 kN and live load is 12 kN for a factored shear force of 35.328 kN. The nominal shear force is 47.104 kN, less than 192.802 kN concrete capacity. Design recommendation as follows. FC prime equals 42 MPa, Fy equals 414 MPa, length of span is 2000 mm, thickness is 200 mm, main bars of grade 414, 10 mm bar at 110 mm on center, temperature bars of grade 414, 10 mm bar at 215 mm on center, bottom bars of grade 414, 10 mm bar at 450 mm on center both ways. Thank you for watching. If you find this video helpful, please like, share, and subscribe to this channel.